Okay, good morning to one and all. Today we're going to discuss system programming. This is one of the course requirement of MS Software Engineering. The prescribed textbook is System Software, an introduction to system programming, published by Edition Wesley by Beck. As per the course requirements, you are supposed to complete CAT exams, PBL review, and terminal exam. The method of evaluation for CAT assessment. For 1, we will conduct examination for 50 marks. The weightage will be 15. Similarly for CAT 2, project based learning, we will conduct 3 reviews. Review 1 5 marks, review 2 5 marks, review 3 10 marks. In terminal examination, we will conduct for 50 marks, the total 100 marks. Based on that, the grade will be assigned by the controller of examination. Okay, then coming to the system programming, what is the need when we are going to apply these things? This is more requirement for this. What is a software? Anyone can define a software? Because nowadays most of the companies, they are developing different kinds of software. What is a software? Software is a collection of computer programs, procedures, associated documentation and data. If you go through many books and all, there are a lot of kinds of softwares are available. Application software, system software, etc. etc. So application software means it is only developed for satisfying a particular end user. In end user perspective, we are going to develop a software that is an application software. Of course, we are using an embedded software. It means a hardware component and a software component we are embedded in a electronic that we will be considered as embedded software. Coming to the system software, for smooth running of the product, we need to use the system software components. Assume that you are developing a program with C or C++. There we have to use the tools of the system software. Assume that a text editor, so where we are going to type your C programming and all, so we have to type in a C the program either in C language or C++ or Java. We need to use editor, that is called an editor, text editor. Similarly, that program cannot be understood by the system, so we need to use a translator. So these are all because the languages, either high level languages or middle level languages or low level languages, all these languages sometimes cannot be understood by a machine, so that we have to provide a machine understandable language. For that we have to use an editor, a translator, then a compiler, etc. etc. So these are the main components of the system software. Coming to this, as a people, we are developing application software, but these application software most of the time in high level programming language, these cannot be understood by a system or a machine, so that we have to use a compiler, an assembler, a microprocessor, a loader, a text editor, a debugger, etc. etc. and file system, memory management system. So this is the overview of the main system software or system programming. Coming to this, what else we are going to study in this particular subject? The system software includes assemblers, linkers, loaders, microprocessors, text editors, compilers, operating system, debugging system, source code control system, database management system. Of course, these some of the things are optional. Assume the database management system, it itself is a core subject, so we will separately learn all these things. Source code control system, that is different. Debugging system, that is operating system alone is a separate system. So compilers, text editors, microprocessors, loaders, linkers, assemblers we need to complete in this particular subject. Coming to this, what is an assembler, what is a loader? Normally people are confusing with lot of things. Assembler, it takes a source program, particularly in assembly language program. So it takes a source program, particularly in assembly language program. It converts the source program into an equivalent machine understandable code. So that part we want to call it as an object program. So assembler role is it receives a source program, that is an assembly language code. So it will convert an object file. Normally instead of source program, that means instead of source program we can take assembly language program, high level language program, say Java program, C program, anything. There instead of an assembler we have to use a compiler. Again that will create an object file that is called .obj file. Then we have to use the concept of loader. This loader duty is to place the object program into memory locations. There we have to store the main program, that means the object program that should be ready for execution. This is the link between assembler and loader. So we can deeply implement the same thing with the concept called assemble and go loader. We will discuss the same thing in future classes. So coming to the relation where the linker. So if it is a one program, then we can use directly a loader. If you are using more than one object programs, then the linker has to connect all the object programs. Sometimes one program may be depend on some other program, so that can be linked together and it will be ready for execution. With the help of loader we will place the same thing into a memory. So in this way, assembler, linker, loader, we have to combine all the features. Then sometimes while you are writing a program, whether it is a high level language or an assembly language, sometimes we may use some kind of subroutines, some kind of macros. Of course macros concept is different with subroutine concept, but we have to combine these two things. So that we need to discuss macroprocessor and assembler list relation. Sometimes we may develop a program with macros. So macro means whenever we want to minimize the program concept and all, minimize the size of the program, that time we can use the program, so that the program with macros will be supplied to the macroprocessor. Then the macroprocessor simply expand the given assembly language program or a high level language program without macros, so that the macroprocessor receives a program with macro definitions and it will expand the program without macro definitions, so that this will be supplied to an assembler. You see, macroprocessor, earlier we discussed directly a source program supplied to the assembler, then assembler will convert the program into equivalent object code in a proper format. But here an assembler simply receives after expanding the program by the macroprocessor, and then only we are simply generating the object codes. So in this way we are going to discuss some of the techniques and tools that are required to satisfy the system software. So whenever we are going to develop any kind of system software, the system software components are always machine dependent or machine independent, so that first of all we need to study about the architecture of the system. So that in this particular course we are going to simulate the things with the help of two things. One is SIC and one is SIC-XE architecture. In coming lectures we will discuss on that. So as a whole we should have some background knowledge on few things like machine code. What is a machine code? We know that an binary code or a machine understandable language is nothing but a machine code. Similarly, instruction formats, we have different kinds of instruction format. Assume that 1 byte instruction format, 2 byte instruction format, 3 byte instruction format, etc, etc. And addressing modes, there are so many kinds of addressing modes are available based on the machine architecture. Assume that simple addressing mode, direct addressing mode, indirect addressing mode, implicit addressing mode. So like that there are different kinds of addressing mode. Then we have to get the grip over the registers. So here with the help of registers only we are going to handle any kind of thing whenever we are using a system component. So accumulator is one kind of register, general purpose registers and special flag registers, etc, etc. So in this way we are going to complete the topic. Thank you.